Hello and welcome to week 2 of the journey to Utopia. Today we're going to be going over the list of parts and we're going to be going over 3 experiments. On Tuesday we're going to create the winch, and then on Wednesday we're going to create a nice fun dune buggy for the kids, and on Thursday we are going to create a search beacon. I can't wait to get started. Let's go. So we are going to be starting with the list of parts. That's what they look like for Monday, Tuesday, Wednesday, Thursday, Friday. Right, so Monday we're going to create a winch where we're going to simulate carrying this heavy sandbag. That's going to simulate us removing the lander out of the sand. On Wednesday, we're actually going to go over the dune buggy design. That is my rough sketch design that I'm going to show you. I'm going to cut it up and we're going to make our own little dune buggy that's gonna propel across with the balloons. Right. So finally, on Thursday, we're gonna go through the search beacon exercise. We're gonna use one of these little nice LED lights to shine a ray through one of these straws with the help of some jello and some silver glitter spray paint. All right, let's get started. We come back here to the first day. Here we go. All right, so the lander is stuck in some orange sand on Utopia. How do you get it out? This is what we have to do. So, a winch is a mechanical device that uses leverage into a pulling or pushing force. So it actually amplifies the input force so that you can pull or push on a heavy object such as your lander stuck in the sand. So, first thing you gotta do just to demonstrate that, you need to apply a force across a radius. So we're gonna wrap the rope around this can, okay? And then we're gonna tie it. I like to do a double knot just to make sure it doesn't go anywhere. We're actually gonna add some slack to the rope. We're gonna let the rope sit down a little. And we're gonna go around the bottle for 2 revolutions before we actually lift up and then twist. So you see, I'm not putting a lot of force, but I'm actually lifting the heavy load we're simulating with this 1 pound mass of rice. And so as you keep on going, it's slow, it's sturdy, but it will not go anywhere. And so in the second, now I'm gonna take this off. I'm gonna cut it off with the pair of scissors. And then now we're gonna do it with something that's got less radius, so less mechanical advantage, less leverage. We're actually gonna use a marker. All right, so same thing we wanna do. We wanna create a little slack in the rope. We wanna roll up the rope a little, maybe 3 revolutions, and then pick it up. And then we slowly start to turn. Now, if you notice, my forearms are actually turning over. I'm using more force. And so I have to use more force to create the same mechanical advantage, because this time my radius is not as big. So the bigger the radius, the more effective the winch is. It's kind of the same concept as a gearing mechanism. But for right now, we're just gonna focus on the winch design. So on a winch, you wanna have a big gear that actually is gonna turn and create a huge mechanical advantage for you to lift heavy objects such as the lander in the sand. And so a variation we can actually do with this lab for the kids, other than just lifting, if you find that you've got a little bit of extra time at the end of class, is actually pulling something across the table. And that actually shows friction. And friction is the resistance to motion. So there's a few forces we've already introduced the students to. We've introduced them to gravity, we've introduced them to friction, we've introduced them to propulsion. So now you actually get to show what friction is. So for me to actually pull this across, right, I have to apply a force. So if I put this back, what a winching mechanism does is it makes it easier for me to drag it across like that towards myself, and that's how you free the lander. Yay! So we're gonna move on to day 2. All right, so I just need to put sellotape around the last wheel. And if you really want to get the wheels perfect, I mean, you could get some sandpaper and actually sand these down with the kids. So this exercise is actually a very flexible exercise because the students get to, you know, kind of self-explore at their own pace. And that's the whole fun and interactive aspect of these challenging labs. They're adaptable. And so you kind of have to go with the pace of the kids, because some kids just get this stuff like that. And some kids, they get this stuff, but you gotta take your time with them. All right, so moving forward, I am now gonna measure out the wheelbase. That's what the wheelbase looks like. So I'm gonna cut that out, but before I do, I wanna create some room for my wheels. So what I'm gonna do is take a pen, mark this area out, mark that area out. That area needs to get cut out. So now that we have our wheelbase and our chassis developed like that, what we wanna do is make sure that these can spin, right? And so to do that, what we're gonna do is we're gonna add a little strip of paper like that. You're gonna sellotape the back of it and then feed your axle through it. And then you're gonna sellotape the top of it like that so that it can actually spin. All right, so now we've got spinning wheels. Look at that, yay. So I'm gonna take this piece of card paper again, cut it off just like that. So after I've cut it off, flip this upside down and put the little piece right over like that. Take the sellotape, cut it off. Sellotape this down. Take the sellotape off, cut it off, and finally, voila. We have a wheelbase, okay? So, the next thing is this wheelbase needs a propulsion system before we can put the shell on top of it, is what I'm trying to say. All right, so what I would do is, all right, so we actually have our little car and it is ready to race. You can actually use bottle tops and, you know, as wheels too, and you can just drill in a hole punch a hole into these little bottle tops, and then they can sit on the wheels like that at the end and kind of rotate, which is also pretty cool. And another thing you can do is actually cut these skews down to size and then fix the bottle tops right on the end. And so when you flip over, you actually have your car on wheels that's ready to ride. Just give the wheels one more turn, make sure they rotate. All right. Awesome. All right, so moving forward, now we need to come up with the balloon cart. We need a straw, and we need all right, so as you're doing this, you really need to remember to put a lot of tape. Feed the straw into the balloon and then tape it off, okay? Just give it a test to see if it's leaking, blow it up. I don't hear anything. I think we're good to go. All right, let it deflate, sit it down. I'm gonna put it in there, just with a little room to spare on the back end. So when you actually pick your cart up, you can go ahead and blow it up. All right. There's the balloon, let it go. Oh, I had the sellotape in the way. Come on now. Wow. That actually worked out better than I thought it would. down. All right, in 3, 2, 1. That actually works. Chassis actually works on that design. And now I'm gonna cut out one shell, and you only need to draw one part of the shell on your card because you can actually take that template and actually cut out another side of your shell on another piece of card that I have there. So I'm gonna cut this off real quick. Now I am just drawing around my template that I've already cut out, and I'm gonna glue that until we've got that little card made up. We're actually gonna sellotape that, and that should be the end of our dune buggy. So stay tuned to see the end product. And that is what one of our designs for the dune buggy looks like when you're actually completed. You can put some beams across and actually have the shell mounted onto the chassis. So when you're actually caught up by these massive storms, sandstorms in Utopia, sand everywhere, in your face, in your eyes, how does the pilot find you for the search and rescue? I've sprayed this straw with nice silver metallic paint. It's supposed to give the straw more of a reflective or reflection on it. So now when we actually use it, you can shine an LED through it. So the LED looks like that. And you notice how diverse the pattern looks. So now when we put the straw, it's a lot more focused light. And the focused light is what is used to actually light up your search beacon. So you need a glass medium to make the beam a lot more focused. And so to do that, all right, so now we need to squeeze this clear silicone right into the tube until it's filled. This might take a while, but just be patient. What I'm gonna do is I'm gonna take some card and just let it set in there. Let all of that silicone just set in there and just tap it off. And so now that you have, you know, a shiny surface and some refractory medium. All right, so we have a shiny surface, a refractive index, and the refractive index is the silicon. It plays the role of glass in this experiment. And the shiny surface just helps us bounce that light into more of a beam. So this is actually still a little bit wet, but I just want to give it a go and see if it actually shines the LED light through. So the LED looks like that. It's very diffused. It's not concentrated. The light, you couldn't pick that light out in a sandstorm because it's spread out like this. All right? Now we want that light to be focused so that it's actually a beam. And the beam is what the search rescue helicopter that's inbound to pick us up can pick up. So when I shine that through, oh wow, look at that. That is a really nice beam. It's nice and focused. It's just about double the diameter of the tube. That is what your search and rescue team are gonna find. Thank you very much. Please don't forget to hit the subscribe button. We've got some more fun interactive labs in store for you next week. Have a good week.